Discrete random variables mock exam solutions. Number 1. 2 boxes contain numbered cards as shown below. So one box contains 3, 4, 5, and the other box contains 9, 10, 10. 2 cards are drawn at random, one from each box. Complete the table below to show all 9 equally likely outcomes. So they already filled in here with 3, 9, 3, 10, and 3, 10. Why do they list 3, 10 twice? Because there's 2 different 10s, right? So each one has an equally likely possible chance. 3, 10 with this card, and also 3, 10 with this card. So we're going to follow their example. We're going to do 4, 9, 4, 10, and 4, 10. And then we're going to do 5, 9, 5, 10, and 5, 10. Repeating 10 because there's 2 10 cards in the second box. Okay. Let S be the sum of all the numbers on the 2 cards. So write down all the possible values of S. Okay, so we're going to do the same thing here. We're going to divide this box into 9. And then some of these are going to be repeated, but we're going to do 12, 13, 13, because we did 3 plus 9, 3 plus 10, and 3 plus 10. We're going to do the same thing with 4 plus 9, 4 plus 10, and 4 plus 10. And then we're going to do 5 plus 9, 5 plus 10, 5 plus 10. Okay? Find the probability of each value of S. Now, if you look at this, only some of the values of S are really distinct values, unique values of S, right? There's 1, there's 2, the other 13s are repeated, there's 14 repeated, and there's 15. So there's really only 4 different values for S, but they have different probabilities, right? So let's do this. We're going to say that the different possibilities for S, there's actually only 3 unique ones, which are 12, 13, and 14. Those are the unique possibilities. But each one of those has a different probability of happening. So the way we figure out the probability is we're going to count how many occurrences of each one happen. So how many different 12s are there? There's only 1. Okay. How many different 13s are there? There's 1, 2, 3. How many different 14s are there? Oh, I'm sorry, I forgot 15 here too. There's 15 is also one more distinct possibility. Okay, how many 14s are there? 1, 2, 3. How many 15s are there? 1, 2. Okay. And how many possibilities total are there? There's 9 here, right? So I'm going to divide each one of these by 9 to get the probability. 1/9, 3/9, 3/9, and 2/9. Those are the 4 possible outcomes with their corresponding probability. Notice 13 and 14 have a much larger chance of happening than 12, for example. Okay. Find the expected value of S. Okay, remember that the formula for the expected value is to take the outcome value and multiply it times the probability value and then sum them all up. So I'm going to do 12 times 1/9 plus 13 times 3/9 plus 14 times 3/9 plus 15 times 2/9. And so we can do that on the calculator if we want to. Let's see. I think I can just change them all into fraction. 12/9 plus 39/9 plus 14 times 3 is about 43. Is that right? No, it's 42. 42/9. And last of all, 15 times 2 is 30/9. And if we add all those up, 12 plus 39 plus 42 plus 30, 84 plus 40 is 120. So 121 divided by 9. Okay? So the expected value of S is 121 divided by 9, which is 13.444. Okay? Alright. Anna plays a game where she wins $50 if S is even and $30 and loses $30 if S is odd. Anna plays the game 36 times. Find the amount she expects to have at the end of 36 games. Okay, so here I think we could copy down the table that we have here again. So we're going to have 12, 13, 14, and 15. So this is each outcome. And then the probability of each happening, we're going to copy down to 1 ninth, 3 ninths, 3 ninths, and 2 ninths. And then we're going to classify each one according to this. If she wins $50 if S is even. So she's going to get plus 50 if S is even. So for 12 and 14, she's going to get $50. And then she's going to lose 30 if S is odd. Lose 30, lose 30. Okay, now I'm going to do the same thing, sigma xp, except for this time, instead of using this x, we're going to use this x. So we're going to have 50 times 1 ninth plus, or minus 30 times 3 ninths plus 50 times 3 ninths minus 30 times 2 ninths. Okay? And then this is going to add up to the expected value of the money. So it's going to be 50 ninths minus 90 ninths plus 150 ninths minus 60 ninths. Okay, so if we add the numerators up, we're going to have negative 40 plus 150 is 110 minus 60 is 50. So we're going to have 50 ninths. So that's going to be 50 divided by 9. It's about $5.55. Okay, so that means for one game, the expected value is going to be 5.56. Okay, so at the end of 36 games, she's going to have 36 times 5.56. Let's see what that is. 200. So the expected value is going to be $200 at the end of 36 games. Okay? Number 2. Evan likes to play 2 games of chance, A and B. For game A, the probability that Evan wins is 0.9. He plays the game A 7 times. Find the probability he wins exactly 4 games. Okay, so I'm going to do this both on by hand and with the calculator. Okay, so the probability that he wins exactly 4 games means that n is equal to 7, right? P is equal to the probability he wins once, which is 0.9. And then R, which is the number of successes, is he wins exactly 4 games. Okay? So we could use the formula from the formula sheet, which is NR times P to the R times 1 minus P to the N minus R. So that would be 7 factorial divided by 4 factorial times 3 factorial, 0.9 to the 4th, 0.1 to the 3rd, right? So we could multiply all this out, and then we're going to get a number here. Okay, so that's how you do it by hand. And then you could do this either partially or completely using the calculator. When I say partially, it's because you could do the factorial part using the math options. So first you would say, if you were going to do 7 chooses 4, n equals 7, r equals 4, you could go 7, and then you go into math, and then I think you go into probability, and then you go to NCR, and then you put in 4. And that'll give you 35. Is this 35? Let's see. 7 factorial divided by 4 factorial is 7 times 6 times 5, which is, let's see, 7 times 6 times 5. So you said, yeah, it'd be 35. This would be 35. And then 0.9 to the 4th, you could just multiply that out by hand on the calculator, right? The other way you do it with the calculator is you use the Binomial Pdf function. The reason why I use PDF is because we're looking for the probability that Evan wins 7 times. And since this is an equal sign here and not an inequality, we can use Binomial Pdf. And the way you get there is you do second, distribution, and then you go to the second page, Binomial Pdf, and then it asks you for certain numbers, like the number of trials is 7, the probability is 0.9, the x value is going to be 4, that's the, 7, no, that's not right, it's supposed to be 4, sorry, this is 4. 4. Okay, and then paste. And the answer is 0.0229, but 9 rounds up, so it's 0.023. 0.0230. Okay? So, either of those two ways. Okay, for game B, the probability that Evan wins is P. He plays the game 7 times. Okay. So, once again, he's playing 7 times, but this is game B, and we don't know the probability. So, it says write down the expression in terms of P, the probability he wins exactly 4 games. So, we're going to do kind of the same thing again. N equals 7, P equals we don't know, and R is equal to 4 again. So, we're going to put 7 factorial over 4 factorial, 3 factorial, just like we did above. And then we're going to have P times P to the 4th times 1 minus P to the 3rd. Okay, so we wrote down an expression here, and I should have put it inside the square, right? Okay, for the probability he wins exactly 4 games. Okay, then it says, hence, find the values of P such that the probability that he wins exactly 4 games is 0.15. So let's see. So we're going to get this expression again. And we're going to put it here. And then we're going to set it equal to 0.15. And then we're going to try to solve this equation, which is not really that easy. Luckily, this is a calculator test, right? So what we could do is we could put this in the calculator and see what values of P make it equal to 0.15, right? So let's try that. We're going to go into y equals here. On y equals, and then here we're going to put 35. Instead of P, we need to use x, right? X to the 4th times 1 minus x to the 3rd. Okay, and then we're going to graph this, and we're going to compare it to a horizontal line at 0.15. I'm not sure if it's going to even show up. Let's do window, and we're going to make the y max equal to about, 3, because it doesn't really need to be very high. And then we'll make the x max about, doesn't need to be very high either, because P can only range from like 0 to 1 anyway. Okay. Ooh, interesting. So there's our P. Oh, and do you see it crosses at 2 points here? Let's try to do a zoom fit. Oh. Yeah, I don't think we wanted to do that. Okay, so let's fix the, make the y, oh look at that, y min went to negative 560. We don't care about the negative values. Okay, that's better. Okay, so we want to know where are these values of p that make this equation true. So we're going to do second calc intersect first curve, second curve, and then the first guess we're going to put close to this intersection here, and it gives us 0.356. So one of the solutions is 0.356. Another solution is this solution here. Let's try to find that one. Second calc intersect first curve, second curve. And then I'm going to put the guess this time very close to this side. And it tells me it's 0.770. Okay, so these are actually two values of p that make this work out. 356 and 0.770. Okay. Just one more thing. I noticed that I made a mistake on problem 1. On problem 1, when you add up these numbers here, you don't get 121 divided by 9. You get 123 divided by 9. And 123 divided by 9 is 13.7. So, let me fix this too. 13.7. Okay, so that's it for the mock exam. I just want to point out one more thing. One of the problems might say something like, "Oh, find the probability that he wins, like more than 5 games." Okay, and remember, the calculator cannot figure out the probability that he can win more than 5 games. What the calculator can do is he can find the inverse of that. Why can't the calculator find the probability he wins 5 or more games? Because the calculator is kind of dumb. It only can figure out if he wins between 0 and a certain number of games. So we can express this as a complement. We could say the probability that he wins less than or equal to 4 games, and we subtract that from 1, and that would be the same, right? So let's do that. So the probability of x is less than or equal to 4, we can do that with the calculator. We just use n equals 7, p equals 0.9, and r equals, or x equals 4. Okay, and when we do it, we need to use Binomial Cdf. So let's try to do that. So the way you get into Binomial Cdf is the same way as PDF. You do second distribution, and then you go to the second page, Binomial Cdf, hit enter, and then here we're going to put in trials. We're going to put 7. P, we're going to put 0.9. X value, we're going to put 4. And this is going to find the probability that we get 0 to 4 successes. Not just exactly 4 games, but 0 to 4 games. So wins 0 games, wins 1 game, wins 2 games, wins 3 games, wins 4 games. It adds up each one of these. It adds it up for r equals 0, r equals 1, r equals 2, r equals 3, r equals 4. It adds them all up, and that's what Binomial Cdf does. And that gives us this number, 0.0257. And then we're going to take this 0.0257, and then we're going to subtract it from 1, and then that'll give us this probability indirectly. You see, so we need to take 1 minus 0.0257, and then we'll get the probability that x is greater than or equal to 5. Okay? Normally we use Binomial Pdf when we get an expression like this where it's x equals to 4, but if you have x is greater than or equal to something, or if x is less than or equal to something, you're going to have to use Binomial Cdf. And if you have greater than or equal to something, you're going to have to do this extra step where you do 1 minus the complement in order to figure out what it's going to be. Okay? Thank you.